Warning lights that move in multiple directions or on multiple planes are nothing new. The idea is become known as the traffic clearing light, but it was seen in the railroad industry very early on with both sealed beams and lamps inside reflectors. The most well-known is probably the Mars light or the 888, which saw use on emergency vehicles as well as railroad applications. However, today what we're going to look at is specifically the later offerings from Federal Signal and Code 3, the Meteor traffic clearing light from Federal Signal, and the Oscil Laser from Code 3, and we're going to look at how they get their orbit patterns specifically, how they do what they do, and how they get the pattern they get. Code 3 had come out with the Stinger, which was a sealed beam lamp using two independent motors to move the sealed beam up and down in a random orbit. That's not what we're getting into today, although they are an interesting product. We're going to look at the Oscil Laser from Code 3 and the Meteor from Federal Signal. The Oscil Laser used a gear with a cutout in it that drove the reflector up and down, whereas the Federal Signal version used a spring to pop the reflector back up and down. So here's a look at how the Oscil Laser functioned. It's relatively simple. You have the back and forth motion and then the up and down motion, and that is accomplished by this gear with the track in it that essentially pulls and pushes the reflector up and down. This negates the need for a spring. However, what it does kind of do is put the bulb in the reflector instead of the reflector around the bulb, which means you can have some contact issues where the ground or the power goes to that bulb. So that would be the weakness there. Federal Signal had the Crossfire assembly, much like Code 3 had the Stinger. The Crossfire was a gear-driven version with two reflectors. They transitioned to the Meteor, which is what we're going to look at, with the spring, as you can see there, and the steady-mounted bulb. They came with a couple different bulb options, but the bulbs were always stationary. The way they worked was somewhat similar, except you have this sort of popper lever, I guess is what I would call it, that pops the reflector up and down with the spring pulling it back to its home position. If you disengage that lever, you just get an oscillating lamp. Once that lever is re-engaged and it contacts the flat side of the drive wheel or drive gear, it starts popping the reflector up and down, which is an interesting design, and it does allow for the bulb to be stationary out front. In this case, in H1, they also used 795s, I believe. Regardless, this one's an H1, and the bulb is angled into the reflector. One of the things we'll look at here is the difference in pattern that these mechanisms provide. The Federal Signal model does what I would call an M and then a reset. So it does an M and then it slides back in a sort of horizontal motion, whereas the Code 3 does an S pattern in both directions. So it's moving up and down in both directions, whereas the Federal Signal moves up and down and then slides back with just a horizontal movement. So we'll look at the Code 3 Oscil Laser first. This is the pattern that it is making, essentially. You can kind of see it's going up and down in both directions, which is consistent with the literature that Code 3 put out. My tracing might be a little bit off because of the surface I was recording on, etc. But this is the general pattern. You get it in both directions. You get up and down, left and right movement in both sides of the cycle, if you will. There's no reset. It is a horizontal and vertical warning motion throughout. Now we can take a look at the Federal Signal model, the Meteor, and we can see that it kind of makes an M and then it swoops back on a horizontal only. That's based upon how it works with the spring mechanism. I traced it out here, and again you kind of get an M and a reset, an M and a reset. Is that more or less effective? I guess you could argue that either way. The reset may keep you from missing some warning. In other words, the constant up and down, you could miss catching someone's eye, whereas the reset, you know you're going across a specific plane. So is one better than the other? I don't know. I think they both work quite well. They're both pretty low amp draw. They both use a single motor. They both use a polished reflector. There's pros and cons to both. The Federal Signal was offered with several different reflector types, a high and a low profile, so I guess there's that. Also different motor speeds were available. But all in all, I think they're pretty equivalent products, and the difference in their orbit is more interesting than it is really important as far as warning power. And it should be noted that these particular devices are pretty much out of favor now anyway, as LEDs have pretty much ruled the roost as far as warning power. I also even heard the argument previously, back in the days of halogen lights, that a traffic clearing light wasn't really any brighter than any given flashing halogen lamp of the same size, just because there was a lot of opportunity to miss the signal, if you will. So there's always that debate. But traffic clearing lights obviously played an interesting role throughout lighting history, and this is a look at the mechanisms and subsequent patterns of two of the later versions from Federal Signal and Code 3. Thanks for watching.